Hey everybody, this is Mr. Clapp, and what I'm going to try and explain is how you would make a scale model. And for our purposes, I'm trying to answer a question that I've actually had for a pretty long time. Because I think we know the Milky Way is really big, and we know the universe is big, but how big is the universe, right? So how big would the observable universe be if the Milky Way was shrunk down to the size of a dime? And I think this is a pretty phenomenal question. We know the Milky Way is really big, and if we made a Milky Way completely out of salt, it would stretch from here halfway to the moon. But if we shrunk it all the way down to the size of a dime, how big would the observable universe be? And so what we did is we had to go ahead and look up these values. And it turns out the actual size of the observable universe is about 96 billion light years. And we know the actual size of the Milky Way is right around 100,000 light years. So 9.6 billion times 10 to the 10th is 96 billion represented in scientific notation. And 1.05 times 10 to the 5th is the actual size of the Milky Way in standard notation. So we also had to figure out the scale size of the observable universe. That's what we're looking for. The scale size of a dime, it's about 1.5 centimeters, or 0.15 meters. And if we plug all this into an equation, again, it's the actual size of the observable universe over the actual size of the Milky Way compared to the scale models. And we're going to go ahead and put these values in. And when we plug through the math, we do some cross multiplying here, moving some stuff around. And what we find is that if this were the case, if we shrunk the Milky Way down to the size of a dime, the observable universe would be about 1.4 times 10 to the 9th over 1.0 times 10 to the 5th. And if we do a little bit of math there, what we find is that's about 14,000 meters or 14 kilometers. So 14 kilometers is a pretty substantial size. And for scale, just to kind of put it in perspective, if you take a look at the city of Reno, and I have my ruler here set up for kilometers, from one side of Reno to the other is just about 14 kilometers. So the size of Reno, and again, remember, this would actually be in 3 dimensions. So it would be the size of Reno, but also up above and down below. That's the scale size of a Milky Way. If you kind of put a dime right in the center of Reno, right at the spaghetti bowl, if you will, that would be the size of the observable universe. All right, thanks, guys. I hope that made sense.